Hello guys, today we're going to be doing the physics quiz for week 3, term 2. So let's start. Question 1. Which components can be used together to experimentally measure gravitational acceleration? Now for this question, you just need to memorize the components. Or if you want to understand about the experiment more, you can go read it from the book. It's section 3.15. But yeah, for this question, you just need to memorize the components. There's nothing else to do. Question 2. A body is free falling near the surface of the Earth. What can be said about the body's acceleration? Now, free falling means that there is no resistance. So resistance is going to be equal to zero near the surface of the Earth. So now we know that the only force acting on it is going to be gravity. And we know that gravity is 9.8 meters per second every second. So what can be said about the body's acceleration? Since the only force acting on it is gravity, and gravity is constant acceleration, it's 9.8 meters per second every second. So the body's acceleration is going to be gravity, which is constant. So its acceleration is going to be constant. And that's it. It's question 3 now. Which of the following are possible outcomes of a zero net force acting on an object? Now, zero net force means that acceleration is zero. It also means that the object could either be at rest or it could have constant velocity. Now, constant velocity means that it has to have constant speed plus constant direction. So now, keeping this in mind, let's read the options. The object remains at rest? Yeah, it could be at rest. So this one's correct. The object decelerates to a full stop. Decelerates means that it has acceleration, but negative, but it's still acceleration. It's not zero. So this one's wrong. The object moves along a straight line with constant speed. Straight line, constant direction, and constant speed, which is constant velocity. So this is correct. The object moves with constant velocity. This is correct. The object moves in a circle with constant speed. It has constant speed, but moving in a circle means that it's not constant direction. So this option is going to be wrong since it's not constant velocity. So on to the next question. A 5 kilogram box is placed on a table. Select the equation that relates the mass of an object to its weight. So this equation you need to memorize W equals mg. And for part B, knowing that the gravitational field strength is 9.8, what is the weight of the box? So we're going to use our rule W equals mg. W, which is we're trying to find, is equal to mass, which we know from the question, is 5 kilograms. So 5 times gravity, which they told us is 9.8, so it's 5 times 9.8, which if we do in the calculator will give us 49, and that's our answer. Question 5. Match each free body diagram with a description that represents it. A box resting, let's start. A box resting on an inclined plane. So let's draw our free body diagram. Here's our inclined plane, and here's our box. The weight of the box is going to be vertically downward, so this is weight. The normal is going to be perpendicular to the surface, so this is the normal. So this is our free body diagram. We go look at the options, this is the closest one to it. Now this force F could be friction, it could be any force. So it doesn't matter if it's left or right, but it's not given to us. We're only given that it's resting on an inclined plane. So we draw our free body diagram and choose the one closest to it, which is going to be the first one here. So that's our answer. A lamp hanging from the ceiling. We draw our lamp, it's going to be pulled down by weight and pulled up by tension. Since it's held up by a rope, we go check, and this is the closest one to our free body diagram. So that's our answer. Now for number 3. A ball kicked at an angle by a child. So let's say this is the ball. It's kicked at a certain angle. This is the angle it's kicked at, and it's pulled down by its own weight. So what is the closest one to it? It's this one. It's this diagram. So that's our answer. Which of the following are possible outcomes of a constant unbalanced force? So constant unbalanced force means that acceleration is not equal to zero. Okay? So, and that it's constant acceleration. So, knowing this, let's look at our options. Okay, yeah. So we know that acceleration is not equal to 0, and that has constant acceleration. So let's read our options. The object remains at rest? No, since it has constant acceleration and that it's not 0. So it has to be moving. The object decelerates at a constant rate. Its acceleration is negative, but it's at a constant rate. So it's constant acceleration. So this option is correct. The object accelerates with a constant acceleration. This is correct. The object moves with a constant velocity. Constant velocity means that acceleration is 0, which we said acceleration can't be 0 if there's an unbalanced force. So this is wrong. The object accelerates at an increasing rate. Wrong, since it accelerates at a constant rate, not an increasing rate. So the last option is also wrong. So this is it for this question. Next question now. Question 7. A relation between the force acting on an object and its acceleration is expressed as force is equal to k times acceleration. So we need to know our rule, which is F equals ma. We have force here, and we have acceleration here. So what's the only thing that's left? M, which is mass. And that's our answer. Question 8. A 1,200 kilogram car, initially traveling at 25 meters per second, stops in 5 seconds once the brakes are applied. What is the magnitude of the force applied by the brakes? So they want a force. So we know that our rule is F equals ma. Now we know mass, but we don't know acceleration. So we need to find the acceleration. Now acceleration is equal to delta V over delta T. So acceleration is going to be equal to V final minus V initial over time. And they told us in the question that it stops. It ends by stopping. So our V final is going to be 0 minus V initial, initially traveling at 25. So 0 minus 25 over time, which they told us is 5. So our acceleration is equal to negative 5. So now we put that in our equation. So force is equal to mass, which is 1,200 given in the question, times negative 5. So our force is equal to negative 6,000. Okay, but now in the question they told us that they want the magnitude, just the magnitude without the direction. So negative positive, this is usually for direction. So magnitude is just the number alone. So our magnitude is 6,000 newtons. So that's it for part A. Now for part B, what is the net force acting on the car if it moves uniformly? Moving uniformly means that it has constant velocity. If it has constant velocity, it means that acceleration is equal to 0. For acceleration to be 0, we need to have 0 net force. And that's our answer for part B. There has to be 0 net force to have 0 acceleration to have a constant movement or uniform movement. So yeah, that's it. For now, question 9. Which statements about a free body diagram are true? This you just need to memorize that it includes all forces, action at a distance and contact, and that it's a simplified sketch of all forces acting on a certain object. So this is just memorization. Question 10. A book rests on an inclined plane making an angle alpha with the horizontal. What are the forces acting on the book? So we can draw the free body diagram. So we have the inclined plane, we have the book, we have the weight, and we have the second. So we have the free body diagram here. This is the horizontal plane. We have the box, we have the weight vertically downwards, and we have the normal. And since it's a rough plane, there has to be friction as well. So we have friction. So what are the forces acting on the object? It's going to be the normal, friction, and the weight. There is no tension since there is no rope or cord, and there is no upthrust since there is nothing mentioned about water. Upthrust is only on water. So yeah, that's it for this question. Next question. Which statements on how to draw a free body diagram are true? This as well you need to understand and memorize what a free body diagram is. So the object on which the forces act can be drawn as a box or a point. You can draw the object as a box or a point. You need to memorize this. The force is represented by an arrow pointing towards the object. This is wrong since it's an arrow away from the object. the magnitude of a force should be added next to the force if given. You need to write the magnitude of a force next to the arrow if you draw it. Unknown forces should not be drawn. This is wrong since you need to draw all forces, whether you know the magnitude or not. And all given values should be added to the free body diagram. This is correct since it has to be a simplified diagram of what's going on with the object. So this is it for this question. Next question. The multi-flash photograph of a puck sliding on a horizontal surface is shown below. What can be said about the motion of the puck? Now we can see that the puck is moving constant distances at constant times. So basically it has constant velocity. Now constant velocity, we said it means that acceleration is zero. And for acceleration to be zero, we have to have zero net force. So net force is equal to zero, which is our answer. No net force acting on the puck since acceleration is zero. And that's it for this question. Now next question. Select the figure that shows no net force acting on the object. So no net force could either mean zero net force or that the forces on the object cancel out. So let's check the diagrams. Here they don't cancel out since they're not opposite and their magnitudes are not equal, so this is wrong. Here these two cancel out, but there's still a force to the right that doesn't cancel out with anything, so net force is not zero, so this is wrong. Here as well, they have different magnitudes and these two are in different, they're not opposites, so they don't cancel out, so this is also wrong. Here it's 10 newtons vertically upwards and 10 newtons vertically downwards, so they cancel out, so the net force is gonna be zero, so this is our only correct answer. So yeah, next question now. The proportionality constant between force F and acceleration A is called the inertial mass m and is represented as. So here we need to know our rule, which is F is equal to ma. Since they want the equation in terms of m, we divide by a on both sides. So here we get rid of a. So we'll get that m is equal to F over a. And that's our answer. So yeah, that's it for this question. Now next question. A trolley and a ticker timer are set up along a horizontal runway. After a constant F acts on the trolley, its acceleration is calculated. The experiment is repeated using the same constant force but different masses. The result of the experiment shows that the acceleration is inversely proportional to what? So let's write our two equations for both trolleys. F is equal to ma. F is equal to ma. Now they told us that force is constant, so these two need to be equal. And they told us that the experiment is repeated using the same constant force but different masses. So we're gonna change the mass. Let's say here it's m, here we're gonna make it 2m. So the results of the experiment show that acceleration is inversely proportional to what? So let's look at what happens to a here. So here let's say that m is 1, acceleration is let's say 1. Here, if we multiply them, our force is also going to be 1, right? So in the second equation, if we found, we said that the forces are constant, so our force is also going to be 1. And since we said mass is going to be 2, which is double 1, so 2m, 2 mass, times what acceleration is going to give us 1? It's going to be 1 over 2, since 2 times half is 1. So from these two equations, we can relate that when we increase mass, with the same force, of course, when force is constant, when we increase mass, acceleration has to decrease. And if we increase acceleration, let's try that, F and F, they're both, let's say 1F is equal to m, a. If this is 1m and we decrease this to half m, 1 here, this is also going to be 1. But half here, acceleration has to be 2 to also give us 1, to give us the same answer. So we deduce that when you increase mass, acceleration decreases, and when you decrease mass, acceleration increases. So they are inversely proportional. And that's it for this question. Okay, next question now. A block is immersed into water and is held at rest by a cord. Drag and drop the correct forces. Now, since I said water, water is always gonna push up. So this is the force pushing up by up thrust. And since they said cord, we're gonna have tension, since cords and strings and ropes always have tension. And the object is gonna be always pulled down by its own weight. So that's it for this question. Let's go to the next one. A group of students pull a glider along an air track with different forces and measure the resulting acceleration of the glider. They plot the results on the graph shown below. The relation shown in the graph illustrates what? We can see that there's acceleration and there's force. So it's it's F and A. So we know that what rule has F and A together? It's Newton's second law, which is F equals mass times acceleration. So the answer is Newton's second law. You need to memorize that F equals ma is Newton's second law. Now the mass of the glider is what? So we're gonna use our rule, which is F equals ma. We can take any point on the graph. Let's say a point here where force is 1. So 1 is equal to mass, which we don't know yet, times acceleration. When force is 1, acceleration is 5. So 1 is equal to mass times 5. So we get that a mass is equal to 1. Mass is equal to 1 over 5. Mass is equal to 0.2. Now, 0.2 kilograms, since in this equation, mass always has to be in kilograms. So we found that the mass is 0.2 kilograms. So we go down now to the question. They're asking for the mass of the glider. We found it to be 0.2 kg. They want it in grams. So to convert to grams, we multiply by 1,000, which if we do, we're going to get 200. And that's our answer. So that's it for this question. Next question. A bucket of mass 2 kilograms is being lifted vertically up by a rope. The bucket accelerates at 1 meter per second squared. Usg is equal to 10 meters per second squared. Now, the weight of the bucket, we're going to use our rule, which is W is equal to mg. We're trying to find the weight, so W is equal to mass. How much is mass? We said mass is 2 times g, which is gravity here, 10. So 2 times 10 is 20. And that's our answer for part A. Now for part B, the tension in the rope. We want basically the force exerted by the rope. So we're gonna use F is equal to M A. Now we're trying to find F, and we know that M is 2 times. We need to get acceleration now. We know that the bucket is accelerating at 1 meter per second squared, and gravity is pulling it down 10 meters per second squared. So now we need to basically get rid of gravity to know the acceleration in the rope on its own, how much the rope is accelerating the bucket. So to basically remove gravity, we're gonna add 10 to the actual acceleration. So we're gonna get that the acceleration from the rope on its own is 11 meters per second squared. So for our force is going to be equal to 2 times 11 meters per second squared, which is 22. Now just to repeat quickly for part B, we know that the bucket is going up at 1 meter per second squared, and at the same time it's being pulled down by gravity at 10 meters per second. Now to find the tension of the rope, we need the acceleration without the effects of gravity, just in the rope. So basically to remove gravity, we're gonna get rid of this 10 meters per second that it's pulling down the bucket by adding it to the acceleration of the rope. So we're gonna have 1 meters per second squared, which is our actual acceleration, plus 10 meter per second squared, which is what gravity is pulling it down by. So we get 11 meters per second squared. So our force is gonna be equal to mass, which is 2 times 11. So it's 22. And that's it for this question. Now question 19. The acceleration of the blocks. Now, F is equal to ma, a constant force F1 of magnitude 10 newtons applied to a block A of mass 1 kilogram, which pushes against block B of mass 4 kilograms. The block slide over a frictionless surface along the x-axis. So we need to find the acceleration, and we already know the force and the mass. So we just substitute. The force is 10 is equal to mass. We need to get the total mass of both of them together. So mass is equal to 1, which is block A, plus 4, which is block B, times acceleration. So we'll get that acceleration times 5 is equal to 10. A times 5 is equal to 10. Divide by 5 on both sides. We'll get that acceleration is equal to 2. And that's our answer for part A. Okay, now for part B, the force acting on block B by block A is how much? Now we know that acceleration is 2, and we know that so we're trying to find the force. So we're gonna use the same rule. Force is equal to mass, which for block B, we want the force acting on block B. So the mass of block B is 4 times acceleration, which we found to be 2. So it's 4 times 2, which is 8. And that's our answer here. So yeah, that's it for this question. Next question now. In which situation is it possible that the block is stationary? So let's look at the diagrams. In A, the forces are not opposite, so there's no way they cancel out. So it can't be stationary. In block C, the forces are again not opposites, so they're not going to cancel out, so the block can't be stationary. Object D is the same thing, they're not opposites, so they're not going to cancel out. In object B, they're opposites, so the block might be stationary if they're equal in magnitude, since they're going to cancel out and net force is going to be 0, so it's going to stay at rest and be stationary. So our answer is block B. And that's it for this question. Now next question. Select the diagram that correctly shows the direction in which the object accelerates. Okay, so here we know that it's gonna be going to the left since there is nothing going to the right, so it's only going to the left. And for up and down, the force going downwards is greater than that going upwards. So we're gonna cancel this out with a little bit of this. So eventually we're gonna end up with a force something like this, since it's to the left and downwards. And this is the only one that's left and downwards. So that's it for this question. So yeah, that's it for the quiz. I hope you understood. If there's anything you don't understand, please don't hesitate to reach out. And yeah, till next time. Bye bye.